Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's lesson, we'll be commencing with our chemistry series, and under this lesson, we'll be looking at the atomic structure. This topic is a foundational topic for all chemistry topic you will ever learn. So under this lesson, we'll be looking at the structure of atom, the subatomic particles, which are the proton, neutron, and electron. And we'll be looking at the atomic number and mass number. We'll also be looking at isotopes and their applications. And also, we'll be looking at the electronic configurations. And lastly, we'll be looking at orbitals, shell, and subshell. So stick with me till the end and let's enjoy the best out of the lesson. So we'll be looking at our first subtopic under the atomic structure, which is the structure of the atom. So looking at the structure of the atom, let's say we have a circular orbit. And in this circular orbit, we have the nucleus inside the circular orbit. So let's call this the nucleus. And in the nucleus, we have the neutron and the proton. So the proton is the positive ion. So let's call this the neutron. And let's call this the proton. So in the nucleus, we have the neutron and the proton. And outside this, we have an electron cloud, which is the electron, which is taking the negative sign. So we can call this the electron. So this is a typical atomic structure. So what can we say about this atomic structure? So let's talk about the nucleus. So we have the nucleus. So what can we say about the nucleus? So looking at the nucleus, we can see it contains the proton and neutron. So we can say the nucleus, it contains the proton and the neutron. What other thing can we say about the nucleus? So looking at the nucleus again, we can say it is very small and extremely dense. So what does this mean? This means that the nucleus is very small and it is extremely dense. So when they are talking about something being extremely dense, it means that the nucleus is heavier and it is closely compacted together. So and another thing we can talk about the nucleus is that the nucleus is positively charged overall. So we can say it is positively charged overall. So this means that all the nucleus is positively charged because the neutron, which is inside the nucleus, does not take any charges. And we also have the proton, which is inside the nucleus, which is taking the positive charge. So we can say the nucleus is positively charged overall. So what other thing can we say about the structure of an atom? So looking at the structure of an atom, we can talk about the electron cloud. So we have the electron cloud. So what can we say about this electron cloud? So this is the electron cloud. What surrounds the nucleus is called the electron cloud. So in the electron cloud, we can see the electron moving around the nucleus. So we can say it contains the electron moving around the nucleus. What other thing can we say about the electron cloud? So we can say the electron cloud contains a maximum volume of the atom, which means it is the most occupied of the atom. So we can say it contains a maximum volume of an atom And lastly, about the electron cloud, we can say it is negatively charged region because it contains an electron moving around the nucleus, which is negatively charged. So we can say it is the negative charged region. So this is all to note about the atomic structure. So on the atomic structure, we have the orbit and we also have the nucleus in the atomic structure. So looking at the nucleus, we can see it contains the neutron and the proton. So the proton is positively charged and the neutron does not carry any charge. So the charge of a neutron is zero. So this nucleus, we can say it contains the proton and the neutron as seen in the nucleus. And we can also say it is extremely small and it is very small and extremely dense, which means the nucleus of an atom is small and it is closely packed together and heavy. So that is the meaning of very small and extremely dense. And lastly, we can say it is positively charged overall. So it is positively charged because the proton of a nucleus is positively charged and the neutron is carrying a zero charge, which means it does not carry any charges. And that is why we said the nucleus is positively charged. So another thing about the structure of an atom is looking at the electron cloud. We can see that the electron cloud contains the electron moving around the nucleus. So this is the electron that is moving around the nucleus. So it is in the electron cloud. So we can say it contains the electron moving around the nucleus. And we can also say it contains a maximum volume of the atom, which means it occupies the most space of an atom. Because the nucleus is small, but the electron cloud is occupying the most space of an atom. And lastly, we can say it is negatively charged region because it is carrying a negative charge. So we can say it is a negatively charged region. And this is all to note about the structure of an atom. Let's look at some examples under this atomic structure. So looking at the examples, we have the hydrogen atom. So the hydrogen atom is like this. So the hydrogen atom has one proton and one electron. So it doesn't have any neutron. It is having zero neutron. And the hydrogen atom doesn't have any neutron because the neutron is not needed to stabilize the nucleus of an hydrogen atom, unlike other atoms. So another example that we can look at is the helium. So the helium has the 4 and 2. So on the helium, we have the 2 proton, we have 2 neutron, and lastly, we have 2 electron. So this is the component of the helium atom. Unlike the hydrogen atom, we said the hydrogen atom has 1 proton, 1 electron, and 0 neutron. The hydrogen does not have any neutron because the neutron is not needed to stabilize the nucleus of an hydrogen atom. But we have the helium atom, which is having 2 proton, 2 neutron, and 2 electron. So remember that when an element have 1 proton, the number of proton must be equal to the number of electron in that atom. Because if you are having 11 proton, you must have 11 electrons to balance up the atom. So that is why we are having 1 proton and 1 electron for hydrogen. And same goes to helium, which we are having 2 protons and 2 electrons. So they must have the same number of proton and electron. And these are examples of atom or an atomic structure. So let's look at some questions under this aspect or this subtopic. Our first question, as displayed on the screen, says that the nucleus contains A. The electron only, B. Proton and neutrons, C. Neutrons and electrons, and D. Protons only. So this question is asking us that what does the nucleus contain? So when we look at the nucleus in the structure of an atom, we can see that it contains the neutron and the proton only. So looking at this question, the nucleus contains the protons and neutrons only. So option B is correct in this kind of question. So proton and neutron is correct. So another example we have says that the overall charge of the nucleus is A negative, B neutral, C positive, and D depends on the atom. So this question now, we said that the overall charges of a neutron is positively charged. So it is positively charged overall. So looking at this question, we can say that the nucleus is positively charged. So option C is correct for this kind of question, which is positive. So positive is correct for this question. And that will be all about the structure of an atom. So another subtopic we have is known as the subatomic particles. And under the subatomic particles, I said we have the proton, we have the neutron, and lastly, we have the electron. So these are the three fundamental subatomic particles that we have. And let's note some things about these subatomic particles. So this is the particles, and we have their charges, we have their relative mass, which is known as the atomic mass unit, which is AMU. And lastly, we have their location. So the first particle, which is proton, what is the charge of a proton? The charge of a proton is positive, which is +1. And the relative atomic mass, which is the atomic mass unit, is known as 1. And lastly, where is the location of the proton? The location of the proton is known as the nucleus. So the location of a proton is the nucleus because the proton lives inside the nucleus of an atom. And we also have the neutron. So the neutron does not carry any charges. So the charges of a neutron is 0. And the relative atomic mass, which is the atomic mass unit of a neutron, is also 1. And where does this neutron live? The neutron lives in the nucleus. Remember we said that the proton and neutron are what contain the nucleus. So the proton and neutron lives in the nucleus. So that is why we are putting their location in the nucleus. And their atomic mass unit, which is known as AMU, is 1. And their charges, the proton carry a charges of +1 and the neutron carry a charges of 0. And lastly, on the subatomic particles, we have the electron. So the electron carry a negative charge, which is -1. And the atomic mass unit, which is the AMU of the electron, is 0.00054. And what is the location of the electron? We said that the electron orbits around the nucleus. So these are keynotes to know about the subatomic particles. So we have the proton, which is carrying a charge of +1, and the atomic mass unit, which is AMU. So the AMU, it means the atomic mass unit. So the atomic mass unit is 1, and the location of the proton, it lives inside the nucleus. And we have the neutron, which is carrying a 0 charge, and the atomic mass unit of neutron is 1, and the neutron also lives in the nucleus. So it is the proton and neutron that makes up the nucleus. And lastly, on the subatomic particles, we have the electron, which is carrying a negative charge of -1, and the atomic mass unit is 0.0054. And lastly, the location of the electron orbits around the nucleus. And this is all to note about the subatomic particles. So let's look at some examples under these subatomic particles. So one of the examples that we have under the subatomic particle is by looking at what contain several atoms of elements. For example, let's say we have the carbon atom. Looking at the carbon atom, you can say it contains 6 protons. And like I said earlier, I said if a particular element is having a particular proton, it must have the same electron to balance up the element. So we can say it also has 6 electrons. And lastly, it has 6 neutrons. So this is what makes up the carbon atom. So the carbon atom has 6 protons, 6 electron, and 6 neutron. And we can also look at another examples of elements under the subatomic particles. So we can look at the oxygen atom. We can say the oxygen atom has 8 protons. So it has 8 electrons. You can see the number of protons is also the same as the number of electrons. And lastly, it has 8 neutrons. So this is what makes up the oxygen atom. And we can use the subatomic particles to determine what makes up a particular atom. So let's look at some questions under this subtopic. The first example we have says that the particle with the smallest mass is A proton, B neutron, C electron. So to get this kind of question, looking at this table, let's look at the atomic mass unit, which is the AMU. So we can see the proton has a mass of 1, the neutron has a mass of 1, and lastly the electron, which is having a mass of 0.0054. So looking at this table, which one do you think has the smallest mass unit? So we can see that when we trace this back, we can see that the electron is having the smallest mass unit. So for this kind of question, the electron is correct, which is the option C. The second question we have says that the identity of an element is determined by the number of what? A electrons, B neutrons, C protons. So looking at this kind of question, the identity of an element is always determined by the protons, which is also the same as the atomic number. So we'll be talking in details about this when we get to atomic number and mass number. So just bear in mind that the identity of an element is always determined by the numbers of protons, which is also the same as the atomic number. So protons is correct for this kind of question. So option C is correct. And the last question we have says that a particle with no charge is the A electron, B proton, and C neutron. So this kind of question, you can see, looking at this table, let's look at their charges. The proton has a charge of +1, the neutron has a 0 charge, and the electron has a charge of -1. So the question is asking that which particle has no charges. So looking at this table, you can see the neutron has no charges, which means it is having a 0 charge. It doesn't carry any charge. So neutron is correct for this kind of question. So option C is correct. And that will be all about the subatomic particles of an atom. Up next, we'll be moving to the top subtopic we have under the atomic structure, which is the atomic number and the mass number. So what is the atomic number? The atomic number, which is denoted as Z, is also the same as the proton number. So the atomic number is the same as the proton number of an element. So just like we said earlier, we said the carbon atom, it has 6 protons. So looking at this, we said the atomic number is also the same as the proton number of an element. So we can say the atomic number of carbon is 6. So carbon has a 6 atomic number because the proton number of carbon is 6. So the atomic number of carbon is also 6. So we can say oxygen atom. So the oxygen atom is also having 8 protons, just like we discussed earlier. So we can say the atomic number of oxygen is, is also equal to 8. So this is a way we can determine the atomic number of an element. So when we know the proton number of that particular element, we can easily detect the atomic number of the element. So the carbon atom, which is having a 6 proton number, we can say the atomic number of carbon is 6. And also the oxygen atom, which is having 8 proton, we can say the atomic number of oxygen is 8. And so on and so forth like that. You can determine the atomic number of any element by just knowing the proton number. And on the other hand, we have the mass number. So the mass number is the sum of the proton and neutron of an element. So the mass number is equal to the sum of the proton and neutron. So the mass number, which is denoted as A, is equal to the proton plus neutron. And this is a way you can detect the mass number of an element. So far you know the proton number of that particular element, you can easily get the mass number of the element by just adding the proton number and the neutron number to get the mass number. So if an element is denoted as X, we can say the mass number is denoted as A, and the atomic number, which is Z, will be down here. So this is a representation of an element, which is X. So the element X is having a mass number of A and an atomic number of Z. So, for example, the example we had earlier, we said carbon atom is having a 6 proton number and also a 6 neutron number. So we can say the carbon atom, which is C, is having a 6 proton number. So the 6 proton number, which is the atomic number, will be here. And the mass number, which is the sum of the proton and neutron. So the proton of carbon is 6 and the neutron is also 6. So the mass number will be equal to 12. So the mass number will be here. So this is how we get the mass number and the atomic number of carbon atom. So we can get the mass number and the atomic number of oxygen atom. So to get the mass number, we can say the oxygen atom has a proton of 8. So the atomic number will be here, which is 8. We said the atomic number is also the same as the proton number. So the atomic number, which is 8, will be here. And the mass number, so we said the oxygen atom also has 8 neutrons. So we can say the mass number of oxygen will be equal to 8 plus 8. So the mass number will be equal to 16. So since oxygen is having 8 proton number, which is the same as atomic number, and it's also having 8 neutrons, so we can say 8 plus 8 will give us the mass number, which is 16. So mass number is proton plus neutron. So this is how we get the 8 plus 8. So it is having 8 proton and 8 neutron. So 8 plus 8 will give us 16, and we can write the mass number on top. So this is a way you can get the mass number and the atomic number of a particular element. So let's look at questions under this concept. The first question we have says that if an atom has a 15 proton number and 60 neutrons, its mass number is. So in this kind of question, they are giving us the proton number to be 15 and the neutron to be 16. So we can add this together to get our mass number. So mass number is equal to 31. So when you add 15 plus 16 together, you get 31. So option C is correct for this kind of question. So the mass number of that atom is 31. So 31 is correct to this kind of question. The second question we have says that the atomic number is equal to the number of A neutrons, B protons, and C electrons. So this question, the atomic number is equal to the number of protons. Just like we said earlier, the atomic number is the proton number. So proton is correct to this kind of question. So option B is correct. And lastly, the question says that in a neutral atom, electron is equal to what? A proton, B neutron, and C mass number. Just like I said earlier, I said that when you have a particular electron, the electron must also equal to the proton. So for this kind of question, the electron is also equal to the proton number. So electron is equal to proton in a neutral atom. So A is correct to this kind of question. When you have a particular electron, the electron must be equal to the proton number. So A is correct to this kind of question. And that will be all on mass number and atomic number. Moving on to the next subtopic we have under the atomic structure, we have the isotopes and their applications. So what are isotopes? Isotopes are elements with the same proton number So the proton number is also known as the atomic number, and they have but different mass number. So this is a definition of isotopes. Isotopes are elements with the same proton number, also known as the atomic number, but different mass numbers. So examples of isotope, we have the examples. So examples of the isotope is the hydrogen isotope. So we have the hydrogen isotopes. So what are the hydrogen isotopes? We have the protium, which is known as H1. So the protium is having one proton, zero neutron, and one electron. So another hydrogen isotope that we have is the deuterium. So the deuterium is having two one, and it has one proton, one electron, and one neutron. And lastly, we have the tritium. So the tritium is having one proton, one neutron, no, two neutron. So it is having two neutron. And lastly, one electron. Notice that the number of proton and neutron of hydrogen isotope does not change because the proton number, we said it is the same as the atomic number. So everything is also having one here. So they are having the same proton number, which is one proton, one proton, one proton. And we say that if an element is having one proton number, it must also have the same equivalent number of electrons. And that is why we are having one electron, and one electron for each. But the only thing that changes is the neutron number. So for protium, we are having zero neutron, so it doesn't have any neutron. And for deuterium, we are having one neutron. And lastly, for tritium, we are having two neutrons. So this is a typical examples of the hydrogen isotopes. Another isotope that we have is the carbon isotope. So we have the carbon isotope. So we have the carbon 12, we have the carbon 13, and lastly, we have the carbon 14. So this carbon 14 is radioactive and it is used for carbon dating. So these are examples of carbon isotopes. We have the carbon 12, carbon 13, and carbon 14. So this carbon 14 is radioactive and it is used for carbon dating. So we'll be looking at the applications of isotopes. So under the applications of isotope, we have the carbon 14, which is used for archaeological dating, or carbon dating. So it's either the two. So the carbon 14 is used for archaeological dating or carbon dating. Any of the two is correct. And we have the cobalt 60. This is used for cancer radiotherapy. And thirdly, we have the iodine. 131. This is used for thyroid diagnosis. And lastly, we have the uranium 235. This is used in generating nuclear energy. So these are applications of common isotopes that we have. We have the carbon-14 used for archaeological dating or carbon dating. We have the cobalt-60, which is used for cancer radiotherapy. And we have the iodine 131, which is used for thyroid diagnosis. And we have the uranium 235, which is used for nuclear energy. So this will be all about isotopes and applications of isotopes. So when we go in detail into isotopes, we will discuss about calculations of isotopes. So let's look at some examples under this concept. Question 1, as displayed on the screen, says that isotopes have the same number of A electrons, B neutrons, C protons, and D mass number. So from the definition of isotope, we said isotopes are elements with the same proton number or atomic number but different mass number. So this question is asking that isotopes have the same number of what? So we can say proton number is correct because isotopes are elements with the same proton number. So proton number is correct to this kind of question. So option C is correct. And the second question we have says that carbon-14 is used for A, energy production, B, carbon dating, and C, water treatment. So this is the application of isotopes, and under this application, we says that carbon-14 is used for the archaeological dating or carbon dating. So carbon dating is correct to this kind of question. So option B is correct. And this will be all on isotopes and applications of isotopes. Moving on to the next subtopic under the atomic structure, we have the electronic configuration. And electronic configuration tells us how electrons are filled in the shells and subshells around the nucleus. So electronic configuration tells us how the electrons are filled in shells and subshells around the nucleus. So looking at these electronic configurations, the electrons are filled from the lower energy to the higher energy. So what this is telling us is that the lower energy is filled first before the higher energy. So these are what to note about the electronic configurations. And we have the shells. So the shells that we have are the K, L, M, N shells. So these shells, we have a number that we assign to these shells. So this is 1, this is 2, this is 3, and this is 4. So these are the shells that we have. And up next, we'll be looking at maximum electrons per shell. So this is the maximum electrons per shell. So what this maximum electron per shell is used for is that it makes us know the maximum electron that each shell can be filled with. So the formula for this maximum electron per shell is given as 2n squared. So for example, for the K shell, we said the number assigned to the K shell is 1. So the maximum electron per shell will be given as 2 open bracket 1 square using this formula. So we have our maximum electron per shell for the K shell to be given as 2. And for the L shell, the maximum electron per shell will be given as 2 open bracket 2 square. So this 2 is the number that we assign to each shell. So this will be 2 square and this will be equal to 8. And the next one we have for the M shell, which will be given as 2 open bracket 3 square. So this will be equal to 18. And lastly, we have the N shell, which is given as 2 open bracket 4 square. So this will be equal to 32. So these are the number of electron or the maximum electron that each shell can take. So for the K shell, it can take the maximum electron of 2. And for the L shell, it can take the maximum electron of 8. And for the M shell, it can take the maximum electron of 18. And lastly, for the N shell, it can take the maximum electron of 32. And this is all to note about the maximum electron per shell. So up next, we have the subshell. So the subshell are the SPDF. So we have the SP, D, and F. So these are the subshell. And the subshell can take the maximum of 2 electrons for S shell. The P can take the maximum of 6 electrons, and the D can take the maximum of 10 electrons, and the F can take the maximum of 14 electrons. These subshells are used in the electronic configuration. So this is what the subshells are all about. And we have their shape. The X has the spherical shape. The P has the dumbbell shape. The D has the clover shape. And lastly, the F has the flower shape. So these are the shape of the subshells or the shape of the orbitals. So we have the filling orders too. So we have the filling order. So for the filling order, we have either what I said here. We said the electrons are filled from the lower energy to the higher energy. So filling it from the lower energy to the higher energy, we have the 1s, we have the 2x, we have the 2p, we have the 3s, we have the 3p, we have the 4s, and we also have the 3d, and we have the 4p. So looking at this, you can see the 1s come before 2x, the 2s is coming before 2p, and the 2p is coming before 3s, and the 3s is also coming before 3p, and the 3p is coming before 4s, and 4s is coming before 3d, and lastly 3d is coming before 4p, and we have it so on and so forth like that. So the reason why the 3p or the 4x is coming before the 3d is because this 4s is having a low energy, and we said that the electrons are filled from the lower energy to the higher energy. So filling it from the lower energy to the higher energy, this 3D has a higher energy than the 4s, and that is why we are filling the 4s first before the 3D. And this is all about the filling order. And we have examples of elements with electronic configuration. Take for example the oxygen atom with the atomic number of 8. The electronic configuration will be given as 1s2, 2s2, and 2p4. So you can see this case, we have the 1s2 because the maximum number of electrons the subshell of X can take is 2. So we have 1s2 followed by 2x. So we have, looking at this filling order, we have 2s2 because the maximum number of the electron that the subshell S can take is 2. So we have the 2s2. And moving to the next one, which is the 2p, we have the 2. So this is supposed to be 2. So we have the 2p4. So looking at this, adding all these numbers together, you can see it gives us the 8 that we have, which is the atomic number. So this is 2 plus 2 plus 4. It's giving us 8. So you can see we have 2p4. And the maximum number that the p subshell can take is 6. So because this is just 8, that's why we are putting 4 there. Assuming we have longer atomic number, you can put 2p6 before filling the next subshell, which is the 3s. And it goes on and so forth like that. Another example of element is the sodium. We have the Na. So the Na is having an atomic number of 11. So the electronic configuration will be given as 1s2, 2s2, 2p4, 2p6 rather, So adding these two together, you can see we have 10 already. And lastly, we have the 3x1. So you can see the electronic configuration of sodium. It is having 1s2. So this 1s is filled because the maximum number you can take is 2. So this one is filled. We are moving to the next one, which is 2x. And the 2s is also having a maximum electron, which is 2. So we have the 2s2. And moving on to the next subshell, which is 2p, we have the 2p6. And the maximum number the p subshell can take is 6. And that is why we are putting 2p6 here. So adding these two together, we have 2 plus 2 plus 6. This is 10 already. And lastly, we have the 3s, which is taking 1 electron. So the maximum number that the s subshell can take is 2. But we are having 1 electron here because that is the maximum atomic number that we are having. And this is the electronic configuration of the sodium atom. So this will be all about the electronic configuration. So let's look at some questions under this concept. The first question, as displayed on the screen, says that the maximum number of electrons in the p subshell is what? A2, B4, C6, and D8. So we said that the subshell, the maximum number that the p orbital can take or the p subshell can take is 6. So 6 is correct to this kind of question. So the question asking that the maximum number of electron in the p subshell is what? So 6 is correct to this kind of question because 6 is the maximum number it can take. And that will be all on electronic configuration of atomic structure. Moving to the last subtopic we have under the atomic structure, which is the orbital, shell, and subshell. Remember from what we said earlier, we said the s subshell, it can take a maximum electron of 2, and we have the p subshell, which can take the maximum electron of 6, and we also have the d subshell, which can take the maximum electron of 10, and lastly, we have the f subshell, which can take the maximum electron of 14. So now that we know this subshell and their maximum electron that they can take, how do we know the orbitals of this subshell? So for the four subshells, so let's say the number of orbitals. So for the first subshell, which is the s subshell, so you can take the maximum orbital of 1. How do we know this is 1? So this is the orbital. So to get the number of orbital, you just have to divide the maximum electron that each subshell can take by 2. So 2 divided by 2, which is 1. So this is the number of orbitals that the subshell, which is s subshell, can take. So how do we fill in these 2 electrons in this orbital? So we have the 2 electrons to be represented as this arrow. So this is the 2 electron in the orbital of the subshell, which is 1. So this is 1 orbital. And moving to the second subshell, which is the p subshell. So the number of orbital, so 6 divided by 2 will be 3. So the number of orbital will be 3. So we have the number of orbital to be 3. So this is 1, 2, 3. So the maximum number of shell, this is 1, 2, 3, 4, 5, 6. So each electron will be filled in each orbital. So 2 electrons per orbital. And that is how we fill the electron for the p subshell. So we have the number of electron, the maximum electron, which is 1, 2, 3, 4, 5, 6. And the orbital is 1, 2, 3. So the p subshell has 3 orbitals. And moving to the d subshell, so we have the maximum electron to be 10. So we have the d subshell, the maximum electron, which is 10, divided by 2, will be given as 5 orbitals. So we have the 5 orbitals, which is 1, 2, 3, 4, and 5. So we can fill in this electron in this maximum orbital. So we have the 1, 2, 2, we have the 3, 4, we have the 5, we have the 6, we have the 7, we have the 8, and we have the 9, and we have the 10. So this is the number of maximum electron that the d orbital can take, which is 10. So we have 5 orbitals. So the d subshell has 5 orbitals. And lastly, we have the f subshell. So the f subshell is having 14 maximum electrons. So the orbital will be 7. 14 divided by 2 will be 7. So the orbital will be 1, 2, 3, 4, 5, 6, 7. So this is the orbital of the f subshell. So you can fill in the electron by putting it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So it is having 7 orbitals. And this is a way to discover the number of orbitals of each subshell. So let's look at some examples under this orbital, subshell, and shells. So example 1, we have the oxygen atom. So the oxygen atom is having an atomic number of 8. So the electronic configuration of oxygen will be given as 1s2, 2s2, and 2p4. So now that we know that the electronic configuration of oxygen is given as 1s2, 2s2, and 2p4, looking at this oxygen, you can say that the subshell present are just the X and P subshell. So this is the subshell that we can find in this oxygen atom, the X and P subshell. So these are the only two subshell that we can find in the oxygen atom. So how do we know the number of shell that we have? This is just the number of subshell. So the subshell is just the S and P. But to get the number of shell, you know that the oxygen atom is having an atomic number of 8. So we can say the atomic number is given as 2,6, because this is just the number of shell. So we have the 2 and the 6. So we can say this is the K shell and this is the L shell. So we said that the maximum number that the K shell can take is 2 and the maximum number that the L shell can take is 8. But because oxygen is not up to a larger amount of atomic number, it's just 2 and 6, which if we add these two together, we will get 8. So we are just having only 2 shell. So the number of shell present in oxygen, the shell will be equal to 2. So this is 2. But the subshell is just S and P. But the shell present in oxygen atom is 2, which is the K and L shell. So because this is just 2 and this is 6, but the maximum number that the L shell can take is 8. Remember from what we did earlier on electronic configuration, we talked about the shells and the maximum number they can take, which is the formula that we used for 2n squared. So this is the formula that we use. So that is how we can get the number of shell and the subshells in an atom. So let's look at another example. Let's take, for example, the magnesium atom. So the magnesium atom is having an atomic number of 12. So in this magnesium atom now, we can write the electronic configuration as 1s2, 2s2, 2p6. So adding these two together, you can see we are having like 10 already. So and lastly, we have the 3s2. So this is 2 plus 2 plus 6 plus 2, which is going to give us 12. So this is the electronic configuration of the magnesium atom. So looking at the subshell present is just S and P. So this is still the subshell that we can find in the magnesium atom, which is just S and P. But how do we get the number of shell? So the number of shell, we can write the magnesium atom to be 2, 8, 2. So in this case, you can see when we add this together, 2 plus 8 plus 2, it is going to give us 12. So the magnesium atom is going to have, this is the K shell, this is the L shell, and this is the M shell. So the L shell, we said the maximum number it can take is 8. And the K shell, the maximum number it can take is 2. And lastly, the M shell, the maximum number it can take is 18. So in this case, you can say that magnesium atom has 3 shells, because we have the KLM shells in the magnesium atom. So we can say the magnesium atom has 3 shells. And this is a way we can determine the number of shells and the number of subshells that we have in an atom. So this is all about the orbitals, shell, and subshells. So let's look at some questions under this concept. The first question we have says that how many orbitals are present in a p subshell? So looking at this question, the option A says 1, B says 2, C 5, and D 7. So from what we discussed earlier, we said the number of orbitals in the p subshell is 3. It's just by dividing the maximum electron the p subshell can take by 2. So the maximum electron is 6. And dividing it by 2, we have 3. So the orbitals that the p subshell has is 3. So for this kind of question, option B is correct, which is 3. And moving to the second question, the question says how many orbitals are in the D subshell? Option A 1, B 3, C 5, and D 7. So for this kind of question, we said the number of orbitals in D subshell is 5. So how do we get this? It's just by dividing the maximum electron it can take, which is 10 by 2. So dividing 10 by 2, we get 5. So the maximum electron that the d orbital can take is 5, and the number of orbitals in the d subshell is 5. So for this kind of question, option C is correct, which is 5. And the last question we have, it says that sodium belongs to period 3. How many shell does it have? Option A says 1, B 2, C 3, and D 4. So for this kind of question, sodium is given as Na, and the atomic number of sodium is 11. So you can write the shell as 281. So this is the K shell, this is the L shell, and this is the M shell. So the maximum number that the K shell can take is 2, and the maximum number that the L shell can take is 8. So the maximum number that the M shell can take is 18. But because the atomic number of sodium is 11, so we have 2 plus 8 plus 1, which is giving us 11. So the number of shell of this sodium is 3. So we have the 1, 2, 3 shell. So for this question, option C is correct, which is 3. And that will be all on the orbitals, shell, and subshells. And that will be all on atomic structure. If you found this video helpful, don't forget to give this video a thumbs up. Subscribe to Tech and EduSpark Hub for more tech content and educational school lessons. And comment your answer below to this question. What is the subshell present in the chlorine atom and the number of shells in chlorine atom? And until next time, keep learning, keep coding, and I will see you in the next one.